All right. So today we begin our discussion of lecture series number 8, which is loosely tagged as peripherals. And incidentally, peripherals are also referred to as input-output devices. So in literature, you probably come across people that refer to input devices as peripherals. It's one and the same thing. And also just to mention that our discussion of lecture series number 8 actually sets the stage for our discussion of the so-called input-output unit, functional unit as it relates to the von Neumann architecture. If you remember, we highlighted the fact that the main high-level functional units associated with the von Neumann architecture are the input-output unit, the central processing unit, and the memory unit. In lecture series number 7, we went through the central processing unit and specifically focused on how instructions are processed by the central processing unit. And in the process, we actually focused on the subcomponents on the central processing unit and their specific roles during the processing of instructions. Right. So key takeaway point from that lecture series was that the central processing unit is the component that is responsible for the processing of individual instructions associated with software. Right. Lecture series number 8 focuses on the devices, or rather auxiliary devices or input-output devices that are used to elicit input from end users, and also devices that are used to provide output to end users. So what you immediately appreciate really is the fact that if we were to refer to our definition of a computer system, the part of the definition that touches on accepting input and producing producing output for end users to consume is really the central focus of lecture series number 8 and lecture series number 9, essentially. So the outline is as follows. This is going to be a very short lecture series, and I do believe that it's probably going to be one of those simpler lecture series to understand, just because we should be able to relate to most of the things we're going to be talking about here. Right. So we are briefly going to introduce peripherals, and then we will also look at hardware ports, which happen to be a most common way in which peripherals or input-output devices get to be incorporated or integrated to computer systems. And then afterwards, we will look at the broad categories of peripheral devices. It turns out that peripheral devices can fall under 4 broad categories. So you have input devices, output devices, storage devices, and communication devices. And then towards the end, we're just going to walk through a few slides that will introduce some rather unconventional devices. Now, these devices will probably fall into either one of these different categories here. But the reason why we're going to look at these unconventional devices is so we can gain an appreciation of the role that peripherals play in trying to turn these computers into generic devices. What you immediately appreciate, and I hope you'll be able to figure this out at the end of this lecture series, is the fact that the type of peripheral that an end user gets to use is dependent on why they are using that computer system in the first place. If you're a lecturer like Lighton, it's likely that you're going to end up using extensively making use of things like microphones, because Lighton creates screencasts. It's likely that you're going to end up using headsets or headphones, because Lighton sometimes watches videos, right? Movies, uses his device or computer to watch movies, or to, I guess, waste time on YouTube or something. So I hope we will keep that at the back of our minds, back of our heads as we're going through this lecture series. So I guess this has become second nature here. Just to wrap it in again, our definition of a computer is an electronic device that accepts input, processes the input, right? When you process the input, you get information, and presents the changed input, which is information, as output. And we've also emphasized the fact that optionally, what could happen is that the output could be saved to persistent storage, right? And again, in terms of the interaction between the different components associated with the computer here, is you have a sort of situation where input is provided to a computer, right? And the central processing unit is the one that processes the input. The processing itself does make reference to main memory in this case, which should be RAM, I suppose, or read-only memory ROM, and also this memory unit or this memory block here could be viewed as being persistent storage. So in the event that the processing needs to be stored to some persistent storage, then the interaction will be between the CPU and the memory component, right? In instances where the process output needs to be directed back to the end user, like if, for instance, you're watching a video, then after processing, what the central processing unit will do is it will implicitly send back the output to an output device. And one of those commonly used output devices here, I want us to think about the LCD screen on our devices, right? So think of what you typically do as you are browsing through Facebook, for instance, or as you are watching a movie on your mobile device, right? So your LCD screen would be the output. And funny enough, for mobile devices, so-called smartphones, the input device is still the LCD screen, right? Because you tend to, smartphones have this touch screen which acts as an input device as well. Okay. And again, just to remind us that we did introduce the high-level functional units associated with the von Neumann architecture, and we've gotten to a stage where we've discussed the central processing unit alongside buses, right? So what's remaining now is the input-output unit and the memory unit, right? We start our discussion with the input-output unit. So it turns out that the input-output unit fundamentally plays the role of providing that interface between the interface that allows the computer to be able to receive input data and then provide or send output data back to the end user. And essentially, really, what the I/O interface or the interface is associated with the I/O component, what they do is they facilitate the communication that takes place between an end user and the computer system, right? And also, interestingly enough, it's also its other role is to facilitate communication between the central processing unit of the computer and secondary storage, so persistent storage. And you soon realize really that one of the broad categories of so-called I/O devices, subcategories of I/O devices, are what are referred to as storage devices, right? Okay. So peripherals are nothing more than just hardware devices that are generally attached or integrated to computer systems in order to enhance the capabilities of computer systems. Now notice here that I'm saying integrated, attached or integrated, because it turns out that in as much as the most common way of integrating peripherals to computer systems involves physically connecting the peripheral to the computer system, it is also possible to connect peripherals wirelessly to computer systems. Right? Those of you that have, let's say, laptops, for instance, will probably make use of a so-called wireless mouse. Ask yourself, how exactly is communication facilitated between your wireless mouse and your computer? Right? Obviously, communication is performed wirelessly here, right? Could be via Bluetooth. That's a common communication channel that is used to integrate wirelessly integrate peripherals with computer systems. But again, this whole notion of the role that peripherals play is extremely important. This whole notion of enhancing the capabilities of computer systems. Think about this for a second, right? In its vanilla state, there's only so much you can do with a computer system, right? But because of its generic nature, and specifically here, this generic nature, if you remember, is due to the fact that you can swap out different program instructions into memory depending on what you're using that computer for at that point in time, right? So the way that the hardware is going to behave is dependent on the program instructions, or the program instructions that are associated with the computer software that is loaded into memory at that point in time. But it turns out really that there are instances when you might want your computer system to behave in a certain way based on what sort of auxiliary devices you've attached to a computer system, right? So in such instances or situations, the program instructions that are currently loaded into memory are not sufficient to convert a computer, to make a computer behave the way you want it to behave. Case in point, if you're a gamer, it is not enough for you to just install I don't know what games people mostly play these days. I've lost touch with that part of my life here, but it's not enough for you to just install one of your favorite games. It might be necessary that you purchase a joystick and integrate a joystick to your computer so that it is a lot easier for you to interact with the gaming software. It turns out that in as much as you can use your mouse, for instance, to play a game on your keyboard, usually it's the forward arrow, the back arrow, the up arrow, and the down arrow keys. But it turns out that the user experience is significantly more positive when you use a joystick, right? The joystick would be enhancing the capabilities of your computer system, because what you'd effectively be doing is converting your computer into a gaming console, kind of, right? Even better, if you, let's say, if you have, let's say, if you purchase one of these virtual reality headsets, for instance, I guess Oculus Rift or something, Oculus Rift. Right. Yeah, so you purchase one of these fancy virtual reality headsets. For you to be able to use the virtual reality headsets, what you would have to do is you would have to integrate them to your computer system, right? Because it turns out that maybe the program that you'd want to interact with when you put on these virtual reality headsets would have to be loaded onto the computer system itself, right? So the key thing here is to appreciate the fact that peripherals are integrated to computer systems in order to enhance the capabilities of computer systems. You're converting a computer system into something much more than the generic piece of hardware that it is once you purchase it brand new from a computer store, right? Another thing that I would like to draw attention to here is the fact that these peripherals are essentially hardware devices, right? Because they're hardware devices, they have similar characteristics as the part of the computer system that we refer to as hardware, right? So they're tangible, they're physical, we can actually see them. And this is true, right? So things like your mouse, for instance, your keyboard, these are things that you can actually physically see. Now, it turns out really that this whole notion of referring peripherals to being hardware devices becomes a bit fluid when you start making reference to, I guess, software-based peripherals, if you will. Now, those of you that have perhaps experienced sort of situation where your let's say your keyboard malfunctions, for instance, would have been forced to use a virtual keyboard or something, right, on your device. The virtual keyboard could be viewed as still being a peripheral device, because what you're doing is you're using it to interact with the computer. Although technically speaking, you'd be interacting with the virtual keyboard using your mouse. Right now, I don't know if people understand what I mean here, but I'm just gonna say keyboard, onboard keyboard, onboard screen keyboard. There we go. So this is what I'm referring to here. If I was to open up a text file, so this, I guess. Oof. How do I move this thing? Okay. If I wanted to type something here, I could choose to use my keyboard, but I could also use this virtual keyboard here, right, where I get to type text the same way I would if I was using the physical keyboard here. But technically speaking, I mean, I'm of course interacting with this virtual keyboard using a peripheral device, which is my mouse, right? So anyways, two key takeaway points here is that these peripherals are essentially, for the most part, hardware devices, and their role is to enhance the capabilities of computer systems, right? And it turns out that you actually connect these peripherals to the computer system via computer buses, right? The buses are back. And the role of these buses really is to interconnect the peripherals with the main functional units, right? So that would be the central processing unit, for instance, right? And the memory unit in certain instances, right? Excuse me. All right. So it turns out really that these so-called peripherals can be broadly categorized into four main categories. We have, and we're going to go through these in sequence really, but we have input devices. So this would be devices that make it possible for you to provide input to a computer system. And input devices could also be viewed as being peripheral devices that are concerned with the functionality of the computer system that is associated with accepting input, right? You also have output devices. And so these would be peripheral devices that enable the computer system to provide output to end users once the input is processed. So in the event that you're watching a movie, for instance, you would need an output device that will make it possible for you to be able to see the video that you're playing back. You would need an output device that will enable you to be able to listen to the sound that is being played back, right? You also have storage devices. These would be devices that make it possible for processed data to be stored persistently, right? So to be stored persistent storage. These would be things like your hard drive, for instance, right? Your hard drive will make it possible for you to be able to, or for the computer to be able to save to persistent storage medium whatever data would have been processed, right? Very, very soon, once we look at computer storage, you gain an appreciation of the fundamental difference between storage medium and the storage device. Notice here that the underlying theme in these different types here is the word device. These are devices, right? We're talking about a device. There's a difference between a storage medium. This would be an entity which is actually physically used to store data or information, and the storage device. A storage device would be a hardware platform that is used to interact with the storage medium, essentially, right? But you also have communication devices. So these would be devices that facilitate the transmission of data to and from remote computer systems. And I'll leave you with a small little thought. We have a discussion of communications devices here, but when you are on Facebook, sieving through the comments on one of the popular groups, I suppose, or pages, what you are implicitly doing is you're communicating with a remote computer system, right? This is probably some server computer system owned by Facebook, for instance. That communication, that two-way communication that takes place as you are making a request to access some resource or a web page, I guess, on the Facebook servers, sending a request and getting back a response is facilitated by communication devices. And we have a broad range of communication devices. And I do believe that most of these have probably been discussed with you in ETU 1020. So these would be things like routers, hubs, right? These are all network communication devices that are used on computer networks to facilitate communication between remote computers. Great. But key takeaway point here is that it turns out that the other key takeaway point here is it turns out that you typically would integrate or attach these peripherals to computer systems either wirelessly or by making use of so-called hardware ports. And it turns out that the most common way of integrating peripherals to computer systems is via hardware ports. There are some devices, of course, that are connected wirelessly, right? Some of these you've probably seen me use in class. So I almost always, when we had those face-to-face interactions, I would almost always come through with my wireless mouse, just because it would make it a lot easier for me to interact with my computer if I was standing further away from my computer. I also used to come to class with my pointer, right? That laser pointer. Now, the laser pointer in itself, the LED light, the red light that you'd see me use as I was walking us through this slide, that feature of the laser pointer is in no way linked to a computer system, but the part that is linked to a computer system is the feature of the laser pointer that enabled me to move from one slide to the next. So my laser pointer had a back button and three buttons actually: back button, forward button, right, enabling me to transition backwards to my slides or forwards to my slides. And then there was a button that enabled me to switch on the LED light, right, the red light that enabled me to focus on, I guess, some section of the presentation that was beamed up. The feature of the laser pointer that makes it a peripheral device is the part that enables me to transition from one slide to the next. Right? Key thing here I'm trying to latch on to here is that laser pointer is integrated, is typically integrated to a computer wirelessly, right? I don't physically connect it to my computer. It just wirelessly connects, actually Bluetooth. It wirelessly connects to the computer system, right? Same goes for my mouse. I also have a wireless keyboard, and these days really there's a broad range of devices that are integrated wirelessly to these computer systems, right? So things like I have these Bluetooth headsets, right? So I don't have to use the audio jack port for me to be able to connect my headsets to my computer system, right? So I'll just I'll slot in my headsets to Bluetooth, right? This Bluetooth device, and then I'll switch it on, and the Bluetooth device is the one that facilitates that communication between the computer system and the headsets, essentially, right? But key takeaway point here is that peripherals can either be connected physically to the computer system using so-called hardware ports or wirelessly, right? All right. So it turns out that as we talk about these so-called peripheral device, best way to view them or to look at them is from the perspective of the different human senses that we use to either provide input to a computer system or consume the output that the computer produces, right, or generates. And really the senses I'm referring to here are things like our eyes, for instance, right? So typically use your eyes to be able to consume the output, right? So if you're watching a video, for instance, interestingly enough, for those of you that probably, not play games here, but what you see in one of the unconventional examples here is that senses such as the eyes could be used to provide input to a computer system, right? So our ears, our hearing senses, will enable us to consume output in the form of sound, right? Typically use our hands to provide input, right? Think of what you do with those funny, I don't know if people have used these things here, but Xbox Kinect. I don't know if people have interacted with these gaming consoles here, but it's usually the case that certain games, boom, there we go. Certain games will allow you to use hand gestures to provide input to a computer system, right? So hand gestures. All right. I was gonna, and of course our mouth here, right? So we typically would use our mouth to provide input to a computer system in the form of sound. Now I always joke. Not joke really, but I always highlight when I'm having a conversation around this topic. I always remind people that so far, I guess the sense that researchers and people that are working in this area haven't been able to hone is a sense of smell, right? If you think about it, if you look at the different senses associated with the human brain here, perhaps the sense of smell is the only it's the only part of human beings that is in no way associated with either input or output, right? So I do hope very, very soon people will come up with a way of providing output that will involve the use of our the human being's nose, for instance, right? Or perhaps provide input using the nose. That would be a bit weird here, but anyway, the possibilities are endless here. I hope this kind of makes sense. Great. So I thought we'd now briefly talk about this. We did make mention of the fact that one of the most common ways in which data is in which peripherals are integrated with computer systems is through the use of hardware ports. So now would be a good a time as any, I suppose, to have a discussion around so-called hardware ports. So it turns out that, like I said, hardware ports are the most common way in which peripherals are integrated with computer systems. And the role of hardware ports really is just to provide an interface that facilitates the transmission of signals from peripherals to the computer system. And the transmission of signals obviously is by way of the computer bus, right? So from the peripheral is typically connected to the main computer bus, right? And then the signals would be transmitted from the peripheral to the CPU, to the computer, right? And it turns out that these so-called hardware ports can be categorized based on how data is transmitted from the peripheral to the computer system. And fundamentally, there's two ways in which data is transmitted in digital communications, right? It's either data can be transmitted in parallel or serially, right? In the case where you're taking advantage of serial data transmission, the type or category of port you'd be working with is so-called serial ports. In the case where data is being transmitted in parallel, the ports that you end up using are so-called parallel ports, right? So again, two main categories here, right? And those categories can be mapped onto two broad categories of hardware ports: serial ports and parallel ports. So irrespective of whether you're talking about a port such as an Ethernet port, for instance, or USB port, that could either fall into this category here, could either be a serial port or a parallel port. In terms of the way that data is being transmitted here, superficially speaking, the best way to understand serial data communication and parallel data communication is to view this from the perspective of how the bits associated with the data get to be transmitted, in this case from the peripheral to the computer, right? In the case of a parallel port, the data would actually be transmitted simultaneously, right? In the case of a serial interface or a serial port, the data is transmitted one bit at a time, right? If this is a bit confusing here, best way to think about this, and it's probably going to be a bit confusing because we haven't had a discussion of I guess data formats and how data can be interpreted or viewed from the perspective of a computer system in terms of bits, right? But so if you're to think of how data is transmitted one bit at a time, for instance, using serial ports, what we're saying here is that if you are, let's say, transmitting, if you were transmitting, just hypothetically speaking, if you are transmitting data associated with the number 4, right? The number 4 is viewed by the computer not as 4 per se, but it's viewed as it's viewed by a computer as, and I do hope I'm recording this. Yes, I am. It's viewed as a computer as being that, right? So as far as the computer is concerned, the number 4 is 100. Now, again, this 100 that we're referring to here is, again, it's overly simplistic, right? It turns out that data is represented in certain predefined patterns on a computer, and the common way of representing data in the common way in which computers represent data is so-called 8-bit representation. So effectively, what the number 4 would be viewed as a computer is a stream of 1, 2, 3, 4, a stream of zeros. Using 8-bit representation would be like so, right? Now, let's say you're transmitting 4, right? What we're saying is this 4 in serial, for serial ports, this 4 would be transmitted one bit at a time, right? If you look at this visual here, we are saying that the transmission is from, it starts with the most significant bit, which is MSB here, and then followed by the least significant bit, right, which is last. So again, if this MSB and LSB concept is a bit confusing, pause for now. It will make sense very, very soon. But essentially, the bit representation, the most significant bit would be the part that represents a higher order of magnitude associated with particular data that the computer will be processing. So in the case of 4 here, for us to convert the 4 into binary number here, it turns out that each one of these bits is represented by a certain magnitude, right? So this is 2 to the power 0, 2 to the power 1, power 2, power 3, power 4, power 5, power 6, power 7. And so this would be the most significant bit because it's represented by 2 to the power 7. This is the least significant bit. So what we're saying is that for serial communication, for serial ports, the transmission of data is done one bit at a time. So the 4 would be transmitted one bit at a time. So 0 would be transmitted 0, 0, 0, 0, and then 1, and then 0, and then 0, right? With parallel ports, on the other hand, the transmission is done, it's done simultaneously. And the common way of transmitting data is maybe, let's say, 8 bits at a time. So if we were working with a parallel port, then the 4 here would be transmitted in such a way that you'd have 0, 0, 0, 0, 0, 1, 0, 0 being transmitted at a time. At any single point in time, a burst of these bits here will be transmitted, right? Right. So fundamentally, really, ports are categorized into these 2 broad categories. And another thing worth mentioning here is that the specific types of peripherals that are associated with these ports really are quite broad. it turns out that the most popular type of subcategory of ports, so-called USB, Universal Serial Bus, can be loosely associated with serial ports, right? In fact, USB stands for Universal Serial Bus, right? So the transmission of data via USB is fundamentally done serially, right? It also used to be the case that older types of peripherals, like modems, for instance, older PCs, modems, and I guess keyboards typically used serial ports, right? Classic examples, I guess, of parallel ports are so-called CISC interfaces that you typically find on the motherboard, the ones that are used to interface your storage device with the central processing unit, right? Those typically use, those are classified or fall under parallel ports. All right. And in terms of this, the other subcategories, now, we just went through a brief discussion of the two broad high-level categories of these so-called hardware ports, but it turns out that there are other specific types of ports that would tend to make use of as we are interfacing these peripherals with computer systems. And so we're just going to go through a few examples, right? Most common one is so-called USB ports, and USB ports have become so mainstream that literally each and every piece of peripheral that you come across will probably be interfaced using a USB port, right? And in fact, it turns out that characteristic is what has made them so popular. The fact that you can use them to interconnect so many different devices. So you probably can't see this right now, but I typically connect, I actually interface my wireless keyboard to a certain extent using USB, because I have a USB connector that I plug into my computer, and the signal is actually transmitted from the mouse to the computer via that component, right? One other thing that very unusual thing here to mention is that I could also view my smartphone as a peripheral, right? Once I integrate it to my computer using USB, right? I can also connect my phone wirelessly with my computer. Obviously, I think I've made mention of so-called KD Connect, right? So I can synchronize I can actually interact with my computer via my phone wirelessly as well. Right, but the key thing here is that it's USB ports happen to fall under the most recent type of serial ports that facilitates the transmission of data serially, right? But it turns out though that there's actually much more that you can do to so many other devices that you can actually interconnect to computer systems via USB ports. Takeaway point here is we're just highlighting the fact that USB ports happen to be an example of specific ports, right? This is an example of a specific port that we use to interface a peripheral with a computer system. I'm trying to see if I have other devices on my desk here that I could. Essentially all my hard disks are actually interface with the computer system using USB, or the hard disk that I have on my desk right now. I connect my GoPro here when I'm wanting to pull information, to charge it, or to pull information from it to my computer system via USB, right? So the examples here are endless, right? Okay. But it turns out that there are other specific types of ports. So we also have Ethernet ports. These are typically used to interface your computer with so-called network devices. If you remember, we did make mention of the fact that so-called peripherals fall under 4 broad categories, right? So communication devices. You typically connect some of these communication devices using Ethernet ports, right? If you are on a local area network like the UNZA network, for instance, a potential way of connecting your computer to the network is through the use of Ethernet ports. So you typically have an Ethernet cable that you plug in into some socket somewhere. There's a port into the wall somewhere. I think you've seen these in most of the classrooms. And then your computer will also have, this is a mass, it will also have an Ethernet port, right? And the way that you know that it's an Ethernet port here is the icon would typically have icon would typically be associated with you typically have the port will have some associated icon that has like computers that are interconnected with each other. So this would be your Ethernet port. I don't know if there's another Ethernet port that I can. There we go. The other computer that we have here has an Ethernet port right here, right? Another Ethernet port here, right? All right. So again, in as much as some of the ports will not be explicitly labeled, one way of telling what type of port it is or what you need to connect to it is by just looking at the slot itself and comparing it with the pins on the other end, right? So by just looking at these different ports here, I would see that I would typically use this to connect a VGA cable, for instance, if I want to integrate a projector, a computer system. I see a serial port such as this. I hope it is. No, this is a power socket. I see, I hope I'm right here, but I see something like this, and I don't know if this is a VGA cable here or it would VGA slot, but that's besides the point here. But bottom line is when you look at the end of whatever peripheral you want to interface here, or the cable, it will sort of like implicitly enable you to figure out what sort of peripheral you'd have to interface with. You'd have to interface with the computer system using that port. So I would know that this would be a mouse, for instance. I was trying to see if I could find some audio jack somewhere. Probably not. Okay. Doesn't look like this example has what I'm looking for. All right. Interesting enough, what you also notice is in some modern day computer systems, for instance, you are less likely to find certain types of ports, like these weird looking ports here, like this, for instance. This is typically found in older computers or maybe on desktop computers, right? On my laptop, the slots, the ports that I have, pretty much most of them are actually USB slots, right? Of course, I have a port that enables me to plug in my headsets here. That's for audio, I guess. I have an Ethernet port, and I have a total of about this is trying to count here. Actually, I have 2 USB ports, right? And really, the types of ports and the number of ports here is usually a decision that a hardware manufacturer would have to make, right? You strike a compromise between the shape and size of the device, because remember, the ports will typically take up a lot of space. So you want to strike a compromise between the functionality and what sort of auxiliary ports you're going to associate to the computer itself. Another interesting thing here is that what I tend to do myself is, because the 2 USB ports are not enough for me, they're not enough because I would typically, at any given point in time, I would have a slew of peripheral devices connected to my computer. So right now, I have my mouse connected. I have my microphone, which is connected using USB. I have 3 hard disks that I have connected to my computer. I'll just also quickly plug in so that you see I've just plugged in a USB drive, right? My computer should be able to see it very, very soon. Boom. I have my USB drive plugged in. Now you notice that all these different devices, there's so many of them that the 2 USB ports are not sufficient, right? You can always buy You can always buy a so-called USB hub, which is what I have here. And the current hub I have, and I'll probably get a snapshot of this so that I share it. But it has 2 USB ports. So effectively, once I use one of the 2 hubs on my computer to connect this USB hub, I'm converting my computer into a computer system that effectively has 4+1, which is 5 hubs, right? I have another USB hub at work, so I could literally have 10 USB ports, right, by making use of those 2 USB hubs here. All right. You also have audio ports, though. Audio ports, not audio ports. Audio ports, which would typically be used to provide input in the form of sound, right, sound data, and get back sound output, right. So the data that you'd be processing or providing as input is in the form of sound. And I hope you've got into a stage where you're able to put the different pieces of the puzzle together here. The fact that the type of port that you'd be working with implicitly points to the type of data that you'd be interested in processing or consuming. And fundamentally, data can be classified into text, sound, images. That's it. The other types here, I know what you're thinking, oh, but what about videos? Those are just composite, right? Video is nothing more than a combination of images and sound, right? So the type of port could also be viewed from the perspective of the type of data that you'd be interested in processing, right? Some random examples here is so-called PCM CIA. These are usually used to integrate things like memory cards, for instance. And I think I do have a PCM CIA slot in my computer. I wish I'd connected or I'd installed the app that allows me to convert my phone into a webcam here. I could have been showcasing exactly what I'm looking at, but that's besides the point. So it turns out really that these are some examples of specific types of ports that enable us to interconnect devices, right? Again, if I was to use this as an example here, Ethernet port. Is this a USB port? USB port. You can see the icon here. USB port. Some ports that we haven't really touched on here, specifics like, which one is a VGA port here? I guess it would be this one, VGA port, right? USB port, right? So these are just some examples of specific types of ports. Ethernet port, USB port, Ethernet port. Okay. So hopefully that makes sense. But if it doesn't make sense yet, maybe a brief walkthrough of some example devices might help. So we're just going to gloss over specific examples of peripherals that fall into the broad categories of devices that we introduce somewhere at some stage. I don't know it was. So these would be the categories I'm referring to here. So we're going to start off with examples of input devices here, right? Classic examples include the so-called keyboard, right? And so you use this to provide texture data to a computer by typing characters that are associated with whatever text you want to provide as input to a computer system. So when you are busy writing your assignment, for instance, or working through some tutorial problem set, you typically use your keyboard to provide text input. And the way that you're providing text input is obviously use a piece of software that allows you to type text using the keyboard. An interesting thing here to note is that the data itself, in as much as you're providing input in the form of characters, but the characters are converted into bits, right? Because the computer only understands ones and zeros. Again, this keyboard could either be wireless or it could be a wired keyboard, right? In most instances, this could be, in some instances, like in the case of laptops, this could be an integrated keyboard, right? Something that's embedded, or something that's a part of your computer system, right? Now, something to think about here is the virtual keyboard that you use on your smartphone. You know, when you're using, I guess this would be a good homework, right? When you're using your phone, your smartphone, technically speaking, you are not when you're using a smartphone and you want to type text here, you use that virtual keyboard, right? Would we say that virtual keyboard is actually a peripheral device? And if we would say that it's a peripheral device, what type of peripheral device would that be? Is it really a peripheral device? Right? I don't know. I guess something to think about here. All right. Some other types of input devices would be so-called pointing devices or touch devices, right? So things like the mouse that we use. Another touch device would be, I guess, your LCD screen on your smartphone that allows you to provide input using your thumb or your fingers or something, right? Some other pointing device would be like your stylus, for instance. If you are one of those who prefers to use so-called Wacom tablets or something, right? Touch screen. Yeah. Again, the best way to get an appreciation of these different devices we're going through here is from the perspective of the type of data that they are used to provide input to the computer system, right? So text, remember, fundamentally data can be classified into text, images, sound. I don't know if I've missed out anything, but fundamentally that's it. So text, image, sound, right? That's it. All right, I guess it's still on pointing devices here. Perhaps the most widely used pointing device here would be your mouse here, right? You typically use it to do a whole range of things here. And it turns out that there are different types of mice here, and you can integrate them wirelessly or physically, like we mentioned. And this image incidentally is, I guess, a snapshot of, or a screenshot of an older version of the mouse that clearly would need to be connected to a computer using a wired connection, using this cable here. So you plug it in somewhere, right? You probably either plug it into here, right, or maybe via USB port or something. Okay. And so when I was making reference to a Wacom, or so-called Wacom tablet, for instance, stylus, this image shows an example of a stylus, right? This would be, I'm not sure if any of your lecturers use this. This would be quite useful if, let's say, you are taking some math type course. If you've noticed, when I'm annotating these slides, I struggle a lot when I'm writing things down, right? So if I'm writing 1 + 1, for instance, I would literally have to perhaps use my mouse in a very difficult kind of way. And the reason I'm doing this is because I'm using my mouse to do this. But if I had a stylus, right, it would make life a lot easier, because I would literally be using it. I'll be using it the same way I would use a textbook, a physical textbook, right? Literally annotating a particular document using my normal handwriting, for instance. This is mostly used by, I guess you could say, educators, for instance, people that teach maths. If it wasn't for Corona, I suppose maybe I would have probably would have tried to see if I could get into town and buy one of these things so I could showcase how it works. But also for people that do a lot of designing, so animation type work, right? Commonly used, they mostly use these sort of pointing devices. All right, but also examples of touchscreen devices here, classic smartphone, where you typically use your finger, for instance, to interact with the display, right? This could be interacting with apps, right? And there are interesting ways of interacting with the display. If you look at this image, for instance, you could also log in, right, by just and I guess I don't know if this would, technically speaking, if you had to log in using your fingerprints here, you wouldn't necessarily be interacting with the touch screen, but you're interacting with this component here, right? This is the part that has the sensors that will be able to get your fingerprint patterns, essentially. Right. And of course, I mean, it's not just mobile devices. It's usually the case that you find these things in kiosks. So I think I've seen a kiosk. I don't know if that thing is touchscreen, but I've seen a kiosk on at Mandahue, I think. But also, if you use so-called automated teller machines or ATMs, what you notice is that most of them will have some sort of touch screen, right? So you have the option of using the number pad or the keypad, right, somewhere at the bottom, or you can interact with the touch screen device. So you just use the touch screen to specify which sort of functionality you want to make use of, whether you want to draw money or something, or whether you want to just check your balance. All right. But also still on input devices here, you have other very weird input devices like scanners, for instance, card readers and cameras. Scanners are essentially used to make digital copies of hard copy content. So I guess if you wanted to scan, if you've been taking notes throughout the academic year and you want to convert them into digital form, you typically use a scanner to do that. It's kind of interesting here. So commonly used to, in the old days, I guess during my time when smartphones weren't available, you typically use a scanner to make digital copies of photos and be able to share them with other people. Right. These days, I guess the role of scanners has been relegated to just scanning documents that are perhaps in hard copy form, right? So that you convert them into digital form. But also, I mean, there's a recent, I guess, surge in so-called 3D printing, right? And so these would be types of scanners that would be able to create three-dimensional models, right, of whatever it is you're interested in doing. Interesting enough, there are people that are doing crazy things when it comes to 3D printing, like 3D printer, like building houses, for instance, right? Weird things that people are doing. So interesting stuff. Again, these all fall under scanners. But if you're using your traditional printer, let's say, to scan a document, a point to note is that the data that the computer would produce once it takes in that input would be an image, essentially, right? So irrespective of whether the document that you are scanning has text, right, characters, what the end result would be an image. For you to be able to extract the text associated with that image, you'd have to take advantage of so-called optical character recognition, where you try to, or you attempt to convert the image that has been scanned into into text, essentially. And again, I wish I could anyways, uh, if you use Google Drive has a very nifty feature where you can, so using your smartphone, you can literally use your smartphone as a scanner. There's a slew of apps out there. But the thing I wanted to draw attention to here is, let's say you wanted to scan, I'm trying to see if I can find an example here of a piece of text here. I'm just going to mask out something. So what I'm going to do here is I'm going to quickly scan. I'm going to use, and I wish I could connect my phone to, anyways, that's fine. I think I should anyway. I wanted to showcase an example where you get to use Google Drive to scan a document, right? And I wanted to show it in real time here, but I'm looking at the time. Maybe I should. Maybe I shouldn't. I think I should. So what I'm going to do is I'm going to do something rather unorthodox here. I will. And the only simplest thing I can think of, ICT 11, 10, illustration. The easiest thing to do this, I guess, is just to create, I feel stupid right now, but I'm going to, and this is the thing that came to my mind when I was doing this. So what I'm going to do is I'm going to schedule an interaction via Meets, and then I will try and see if I can showcase what I want to showcase here. If I Google Meets, oh, forgot to do something. Where the hell is that? Oh. And I just mindlessly created an interaction without necessarily. Oh, there we go. It's here. So I'm just going to convert this to, or change the time here to 21 hours so that, okay, that's good. Don't send. Hopefully I've gotten the invitation. I think I have. Okay, so what I will do is I will log into Meets. That's a bit weird. Why can I not see this? All right. I'm already connected, but it appears this thing wants me to. Oh, it was the 3rd instead of today. Shit. Okay. Just going to 26th, which is day. Don't send. All right. So what I wanted to do is to just quickly showcase something here, and I'm gonna see if I can log into this. Then I will say join. I hope this works. I'll just pause. All right. So just quickly, I wanted to showcase, and just going to. I hope this won't mess up the audio on the screencast here. Great. So what I'm going to do is I'm just going to share my screen on my mobile device, and hope this works. All right. And it doesn't look like this is working here. Present screen, start presenting, start now. All right, great. So what I essentially wanted to showcase is a sort of situation where, if you notice, if I go to Google Drive, what Google Drive has is some very nifty feature that allows you to be able to, and I do apologize, I should have prepared this up front. It's usually a lot easier and faster if I connect my devices, a peripheral to my computer system. But what you will immediately notice is when you're adding a new document on Google Drive, there's usually an option where you get to scan, right? I don't know if you can see this option here, which says scan. So if I say scan, the scan feature allows me to literally scan a document, right? So in this case, let's say I want to scan this portion of this receipt that I got from Pick and Pay, I guess. I want to make sure that the OCR part is not messed up. Okay, so I scan this document, right? And then I'll say, yes, this is good. All right. Then I suppose I can crop it also. Ooh, wow. This is very strange. Okay, so this scanning bit is it's a bit weird here, but I'm hoping this feature is going to enable me. I hope I do remember how to do this, do I? There should be a way of extracting text too. Okay, let's try and save this, and then I'll try and see if I can. It appears I can't. Okay. I thought anyway. So this would be like the scanning process where I'm converting. I just converted an image right into digital form. But the part that I wanted to showcase here is, and it appears it's not going to be possible here, but I thought I would be able to. Okay, I thought there was a feature that allows you to convert this piece of PDF document to text or something. It appears there isn't. Okay, that's fine. It appears there isn't, and I wanted to showcase. Okay, it appears there isn't, but what I'm going to do is I'm going to do something else because I still want to showcase this whole notion of optical character recognition, so conversion of a digital or an image into its equivalent textual representation. So what I will do is I'll just download this document, and I hope this thing will be able to work. It should be able to work, but I don't. The quality is a bit iffy here, which is why I'm a bit uncertain. Come on. Why can I not download this? Yeah, but I want to download it right now. Why does it say it's going to be downloaded? Jesus Christ. Okay, it appears this thing. So I'm going to stop sharing my screen, right? And then I'll stop sharing my screen, and then I'll try and see if I can access, and I'll log out of here, and I'll try and see if I can access the document from within Google Drive, right, which is here. So I'm just going to go here, and then come on, hopefully be able to access it from here. I should see it here. There we go. And then I'll download this document offline. This is a weird thing. I just want to download the document, and it's taking quite a bit of time, but okay. So downloaded the document. It should be in my downloads folder, right? This is the scanned document. The quality is not that good, but nonetheless, hopefully this will be able to work. But observe, if I go to my computer and just say file scanned, this is the document here, right? By the way, I'll just open it up so that people can see using Ocular. This is a document here, right? PDF document. If I, in its current form, I cannot copy this piece of text because this is an image, right? I can't select this text, you know, I can't select it because this is an image. Compare and contrast with a situation where I'm working with this PDF document, which is born digital. I can literally select this piece of text, copy it across, right? Be able to manipulate it or something. I cannot do this here because the scanning process, when I scan this document, it's converted into an image. For me to be able to make sense out of the piece of text associated with this image, I would have to convert it using optical character recognition to text. And there are tools, there are software tools, application software tools. Like I have nifty tools like PDF to text, for instance, that I can use to convert this to text. So boom, I've converted this document to text, and now I have an equivalent piece of text which is here. And hopefully if I was to open this text using VI, the conversion is horrible as well. Maybe if I said tesseract, yeah, this conversion is horrible as well. Clearly, because I think because of the quality of the scanning, the scanned document, the quality is so bad that converting it to text results in a very poor quality document. So there's really nothing in here, I guess. But maybe what might help is if I Ubuntu tesseract PDF to image. Sorry about that. I guess what I could do is I know I've done this before. It turns out that the quality is sort of like improved if you convert the PDF document to an image, I guess. I wonder if I can, I'm veering off here, but convert. I wonder if I can convert, come on, I can convert this to PNG and then convert the PNG to text. Nothing still. Okay, nothing still. Could not read the table. Okay, so looks like a very PDF to text. Very horrible way of doing this. Doesn't work. Anyways. Okay. Anyway, the quality is bad. But if the quality was pretty decent, we are probably going to be able to convert the piece of text to an image. I wonder if there's another way of doing this. Probably not. Probably not. Anyways, key takeaway point here is that when you scan a document and using a scanner, right? A document that's not born digital. One way of extracting text or characters associated with the document is by undergoing optical character recognition. All right, so some other examples associated with scanners and readers here. We have things that you've probably seen in most of these department stores, the so-called barcode readers. So when you're at the till in ShopRite, for instance, you typically have noticed that the person at the till attending to you will typically scan a document using, they'll scan the product or the item that you wish to purchase, right? And what they do is they use what's called a barcode scanner or a barcode reader. That barcode reader is used to determine pricing information and descriptive information associated with the item that you wish to purchase, right? So there's typically a strip, and I think you've seen this, but for those of you that haven't really seen this, but barcode. For those of you that haven't seen this, this is what you typically see, right? Let's see if we can see barcode readers on vegetables. You typically see see this sort of thing, like if you're one of those who likes to buy this sort of produce, right? This is the barcode itself. So the barcode reader is used to, it reads this to try and automatically determine, right? Obviously, behind the scenes, you're looking up information in some database, but you're trying to look up information. In this case, is pricing information, right, associated with this item. Now, I guess if you know how these things work, I'm sure, I hope none of you have done this. Typically, have characters who would steal by way of you just go at the till, and then, or you are walking around in ShopRite, and then you just remove some barcode from, let's say, a watermelon or something, or a tomato, and then you put it on some expensive item, right? So that you try and fool the system into scanning out an item that is overly expensive at a much lower price or something. I don't know if I'm making sense. But these are typically used in I guess in supermarkets to try and quickly look up information about items that might be on sale. In other large department stores, it's not uncommon to find the people that attend to you as you're shopping to have a barcode reader. Like if you just want to quickly find out details about an item before you take it to the till, you just ask that person, how much is this? Then they'll be able to get out the barcode reader, scan that item, and give you the information you need. But also other types of readers here, I guess the most popular one is the so-called quick response code, right? If you go in book world, you also have barcode readers that are associated with books, right? In the library as well, when you're scanning out, I don't know if our library haven't taken out books in years from there, but I'm sure when you're scanning out a book or you're scanning in a book, they'll use a barcode reader to signal the fact that that book has been reserved, right? So it's no longer available. Manually doing that is tedious, right? So it's one way of automating that process. These days, you typically have found quick response code, or you find quick response code in so many different areas, right? Zampay, for instance, makes use of quick response codes, right? Places like China have gone all out with QR codes, right? So mobile payments are typically facilitated by quick response code. But I want to draw your attention to a quick response code that we associate with our course, right? If you scan this using your phone, this thing will take you to the home page for the course web page or website, whatever you want to call it. This is what we're referring to as a quick response code. So this pattern here is unique to, in this case, a URL. But quick response codes could also be used to encode cryptic information associated to, let's say, an address, for instance. Right? Hope that kind of makes sense. And all right. Ooh, okay, scanners, quick response code. Okay. But also, still on input devices here, cameras have become so mainstream now. We have security cameras on UNZA premises, so in locations that are considered to be extremely sensitive. I do believe our computer laboratory has webcams, right, that constantly take snapshots of the people that are visiting the lab. In the event that something goes missing, you can easily follow up. Banks will have webcams or cameras. The average modern day smartphone will be integrated with a camera, typically a front-facing camera, and a camera on the rear end of the smartphone itself, a so-called selfie camera here. But fundamentally here, if you think about it here, the data that we are providing as input to the computer is very important, right? In the case of cameras, it would be images, right? And like I said, the common use case here is in video surveillance, for instance. Selfies these days, right? Everybody is I guess creating creating what is funny TikTok videos, for instance, right? Typically would make use of these cameras. So this image, by the way, is showcasing like an external webcam. The average desktop computer, for instance, will not come embedded with a webcam. So what you would have to do is you'd have to purchase a webcam. That webcam would be integrated with your desktop computer as a peripheral device, perhaps using a USB port or something. In terms of sound, typically the most widely used input device here would be like your microphone. Right? I have a microphone at home myself, but also on your modern day smartphone will always have an integrated microphone. Why? Because one of the most important functionalities associated with a smartphone is transmission of sound signals, right? You want to be able to make calls, talk to people as you're making those calls. All right. So I guess hopefully that's enough. I mean, this is by no means comprehensive. There's a whole slew of potential input devices that we could include to the list of these things that we're discussing, but hopefully that gives you an idea of the types of input devices that you can integrate with your computer system to enhance the functionality of your computer system. If you're a person that produces music as a hobby, you typically use a microphone to record music, right? Maybe you also have one of those, I don't know if they're called electronic guitars or something, that you'd connect to your computer and be able to record sounds or something. Although that's an archaic way of doing things. Okay, just a quick walkthrough of output devices. Again, this is best understood from the perspective of what sort of data is being produced by the computer, right? Common examples of output devices would be your display devices, right? Most computer systems that you can think of would typically have a corresponding display device. Just because one of the things you'd want to do is to be able to view or to be able to consume output that is being produced by the computer. It's not always the case, but in most instances. So common examples of display devices would be your standalone monitors here that you typically integrate with your desktop computers, right? Your average laptop will come with an integrated display. So does your smartphone, right? Other examples would be, and again, if you think of it from the point of view of the type of data that you're dealing with here, or information you're dealing with here, this would be images, this would be text, this can't be sound, right? I don't know how you display sound on a display device. Well, I guess if you view Audacity, if you want to visualize, I guess, this idea of sound from the perspective of like an application that helps visualize the sound that you're producing, maybe you could say perhaps sound could be visualized using an output device. So what I'm saying here is if I wanted to play back, let's say, if I wanted to play back a pre-recorded screencast, for instance, I'd go here, then I would say, if I can just find that, what implementation, I would come here and then I would say open this. If I play this back using Audacity, what Audacity does is it provides some way of visualizing the sound, right? But this is just to help you. I guess you could say the output from the sound is being visualized using a display device, but fundamentally the way that you consume sound is by listening to it, right? But in this case, I guess you could say you're visualizing the output using a display device because you're actually you're visualizing it using your LCD screen. Right? I hope that's going to make sense. All right. No, don't save. Okay, so another very popular way of eliciting output produced by a computer is through the use of audio output devices. So headsets, for instance, will make it possible for you to be able to play back pre-recorded audio, right? In some instances, you would have your speakers integrated within the device, as is the case with most smartphones these days. But it turns out, though, that you can enhance the functionality of your computer system, in this case your microphone, by integrating it with your headsets. Perhaps you'd be you'd be using headsets so that the sound that you're listening to is much more pronounced, for instance. So that is one way of enhancing the functionality of your smartphone through the use of headsets, right? And those headsets perhaps would be like Beats by Dre or something, right? Perhaps those headsets would be what do you call this? Wireless headsets, right? And the way you'd be enhancing the functionality is to, if you're in a crowded place, you don't want to inconvenience other people, and so you just plug in your headsets, and so that the sound is just concentrated to your ears or something. Right. Again, in all these instances where we are walking through examples, think of these examples from the perspective of what sort of data you're dealing with and how you are enhancing the functionality of your computer system. You also have printers. Increasingly, I think printers are being used less and less. I mean, we make extensive use of printers just because for in-classroom assessments, we almost always have to print out the assessments. For exams, those exams, once they're prepared digitally, they'll have to be printed out on paper, right? So the type of data that you'll be dealing with here is a combination, I guess, of textual data and images. What you're doing is you are transferring the digital data, the data that's in digital form, into physical form, right? Or into a physical artifact, in this case, paper. And again, similar to most of these devices we've been talking about here, you can either interface your computer system to printers using USB ports or even wirelessly. So the UNZA, for instance, has a number of so-called network printers, right? Because most of the printers we use are extremely expensive. These are industrial grade printers. We only have very few of them, right? So if you want to use a printer that's located elsewhere, you get to interact with it via the network, right? So a printer will typically have an IP address associated with it, and so you just specify the IP address where you want to print a document to. Now, if I have a very funny story, a very embarrassing story actually. Is it last year or before last year? I accidentally printed an exam and sent the print job to a printer that was located to the accounts department, right? And we actually had to change the questions of the exam itself. It was a final exam. But you notice that the printer itself, the way that it was interfaced with my computer was through the network. Right. Okay. So you also have so-called storage devices. So we've looked at input devices, output devices, but we also have storage devices. These are devices that will facilitate the storing of data and information to, or persistently, to storage mediums. So this example is just showcasing magnetic, I guess, storage device. So your hard disk, your typical hard disk will be composed of, or your hard drive will typically be embedded with a hard disk inside, right? The hard drive is what we're referring to as a storage device. The same goes for your so-called thumb drive or USB drive. The USB drive has within it embedded a storage medium where data is written to. The USB stick, the physical USB stick that you see itself, in its entirety would be the storage device. And we have a dedicated lecture series where we get to look at the broad spectrum or different subcategories of so-called storage devices, essentially. Okay, and then the last subcategory is so-called communication devices. It turns out that computers these days have become more useful when it comes to consuming resources or data that's available online or on the internet. And the way that you facilitate, or the way that you get to consume information online, is through the use of communication devices. So classic examples of communication devices would be, so-called MiFis, for instance. I got a MiFi so that I can easily buy data or something, or easily buy data at a much cheaper price. Modems, examples of communication devices. So-called routers, if you have a dedicated broadband connection at home, for instance. Right? These are all examples of communication devices that will fundamentally facilitate communication between your computer system and some remote computer out there, a computer which perhaps has resources that you're interested in. Okay, I do believe this is an example of a router here. And by the way, you will notice that this image here has, interestingly enough, yes, Ethernet ports. All right. Okay, and then finally, just to, I guess, help connect the different bits and pieces that we talked about, I thought now would be a good time for us to just walk through some very unconventional devices, that might perhaps fall into a category of input devices, maybe output devices, or in certain instances, communication devices, maybe even both. In all these different examples, I'll leave it open-ended so that you think about these things, right? It will be homework to think about which category they fall under, but I'll briefly explain what it is they do. In certain instances, maybe I'll just spill the beans, I guess, I don't know. But remember that in all instances, think of the devices from the perspective of the senses that are involved in either consuming the data that is processed or providing input. I'm not sure if Zawa makes use of these things, but the people that are involved with conservation, for instance, will typically make use of so-called camera traps, right? And what these devices do is they are automatically activated when they detect some sort of motion. So think of these things as, or think of such devices being dotted across maybe South Luangwa National Park, right? And one of the ways you'd want to use these tools is to try and estimate the population of hippopotamuses, for instance, I don't know, or lions or something. What you do is you strategically position them, and then they'll be activated every time there's movement close by, right? Notice these are motion activated, right? So as part of homework, think about this. Think about the data, the type of data that you'd be working with. Think of whether this device is an input device. Is it an output device? Is it a storage device? Is it both? A common I guess yet another example that's associated with this is so-called speed traps, right, that we have dotted around in most of our roads, especially greatest road, right? It turns out that now I'm not sure if these are motion detected, the ones that we have, but I do remember being a part of this group. We went on a road trip at some point. We were driving from Lesotho to South Africa anyways, and what the thing with the road, the highway we were using, is there were so-called speed traps or speed cameras, right? And the way that they work is they're able to automatically detect if you are going beyond a certain speed limit, and then they'll get snapshots of your license plate, right? So again, I guess you could view those cameras as being motion detected perhaps, and the motion is detected based on whether the camera thinks, if we can use that word, thinks that you're speeding or not. And it's quite easy really to figure out whether you're speeding or not. It's just a before and after snapshot, right? So you take snapshots of the vehicle at different instances, and then based on the rate at which, or the position of the vehicle, you can determine at what speed the vehicle is being driven at. I don't know if that can make sense. Some other unconventional peripherals that you've probably come across here is, and this is a very familiar site, I guess. You go in Pick and Pay. What you immediately notice here is a number of peripherals here. And I shouldn't have said what device here, but what devices are here. This is a peripheral device, I guess, right? Providing input. This is yet another peripheral device, your point of sale. This is a combination of a point of sale system here. There's probably supposed to be a keyboard somewhere here. And something is missing here. There's supposed to be like a barcode scanner, right? This is another peripheral device. So you notice that in all these different instances, you have different data being processed. You have different subcategories of peripherals, whether they're output devices, input devices, network devices, right? Here's a fun fact here. This thing here, which is typically used if you're swiping using your bank card. You swipe in your card, you notice that it's an input device, but you could also view it as being a communications device, because what this point of sale system does once you swipe your card is it initiates communication between this device here and your bank, right? So your bank will be able to detect that this card is linked to, let's say, Lighton's card, right? And the bank would do a bit of processing there and be able to check if Lighton has enough balance in his account. If he does, then the transaction is processed, it's accepted, in which case Lighton's account is deducted or something. So this could be viewed as being an input device and also a communications device to a certain extent, but also perhaps hidden, right? Hidden, something that you cannot see here is that the company, let's say this is in ShopRite. ShopRite has a way of connecting to the internet, right? And one of the ways in which connection to the internet is facilitated by network host on ShopRite premises is through the use of network devices like routers, hubs, bridges, right? Anyways, so hopefully you'll be able to figure out what else is here besides I guess the barcode is missing here. Next time I think we should include an image with a barcode reader. Here's something else. If you use Facebook, I'm sure this is a familiar site. Quick question, I guess the pop quiz here is what sort of data is being processed here? What peripherals can we identify here? What sort of information is being accepted, is being produced, right? How can we, it's clear we see we're using hand gestures here, but what sort of data are we providing to the computer system? Right? It turns out really that when you're thinking of these peripheral devices, the end user is not always a human being, right? So in most of these examples we've been highlighting here, you realize that the peripheral would be facilitating the interaction between a human being and the computer system. But in certain instances like this here, if this is in South Konga National Park here, the motion detection is actually initiated by animals, right? So lions that are roaming around, or gorillas or baboons or something, right? In this example, obviously you need a human being. A human being is consuming the output here. But there are certain rare instances where you can have machine-to-machine interaction. And there's an example that I've perhaps been highlighting here, the fact that I can connect my computer. I can connect my KDE connect, that I can connect my phone, or I can use my phone as a mouse, right? And this is, if I can just open up KDE Connect here on my phone. I can connect it, and I don't know if you can see this, but you just have to take, and here's the thing here. Just take it by faith that Lighton is connecting his computer using KDE Connect, I guess. Take it by faith that Lighton is actually telling you the truth, but seeing is believing, right? Evidence, evidence, evidence. So here's the thing. I'm going to connect my computer back. Good. I'm going to join this call again. And then what I'm going to do is I'm going to showcase how exactly I interface my computer with, let me just mute everything here. I'm going to interface my computer with, I just mute this as well, audio off. I'm going to share my screen, and then I'll use KDE Connect so that I showcase exactly how this works. Unconventional peripherals, right? Machine-to-machine interaction. So in this case, I have KDE Connect. KDE Connect is not part of my work profile. So KDE Connect is this application here. It should be able to come up very, very soon. There we go. I'll open it up. And what KDE Connect allows me to do really is I can, if you notice these different features that I have, I can send files to my computer. It's connected wirelessly to my phone is connected wirelessly to my computer right now because both my computer and my phone are on the same network. This is how KDE Connect works. But something else I can do is I can use my phone as a slideshow remote, right? If you notice the features that come up here, and if I beam up, and you won't be able to see this, but if I beam up my slides, what I am doing now is I'm going forward and back using my phone, right? So my phone is being used as a peripheral, as an input device. And what's actually happening is even though I am interacting with my smartphone, but from the perspective of my laptop, the interaction is happening between my mobile device and my computer system, right? It gets even better. I can also use KDE Connect I can also use KDE Connect here to provide remote input, right? In which case I can use I'm now using my smartphone as an input device. So it's simulating a functionality of a mouse here, right? I guess I could also use it as, I can use it to provide input in the form of what would come to a keyboard. So what I'm typing here is coming from my phone's keyboard, the virtual keyboard on my phone. And you'd probably only be able to appreciate this if I came here and I actually started showcasing what was happening. But anyways, I hope that makes a bit of sense. I hope. Just disconnect here. Go back. It gets even better though. Besides machine-to-machine interaction here, I like giving these examples. Again, this is tied to some of these unconventional ways of providing input. Stephen Hawking, who's deceased now, I guess one of the most renowned physicists of our time, but he had a disability that made it impossible. It was a neurological disorder, and that made it impossible for him to use his limbs, right? So he was unable to use his hands. He was bound to a wheelchair. The only way he could interact with the computer system is through the use of his eyes, right? So if you look up, you can look up this link here to look up how this computer system was designed to actually interpret input coming in from his eyes here. Quick question for us. What sort of data is being sent through is being inputted to a computer system in this case? Yet another example you probably want to look at is similar to the way that Stephen Hawking used to interact with his computer. There was a piece on BBC, I think it was in 2018, I don't know if it was 2019, where again there was this lady, this child that has a similar affliction as this, right? A neurological disorder where she is, which makes it incredibly difficult for her to make use of her hands. And so the only way she can play Minecraft is using her eyes, right? So question here is what sort of data would we be working with in this case, right? For a person who is, let's say, playing Minecraft using a computer with their eyes, right? What sort of data are we providing or are you sending to the computer as input? All right, so to just tie the different bits and pieces together here, just to remind us of the broad categories of peripheral devices. And by the way, this says 3 here because input output are considered 1, but in actual fact these are supposed to be 4 devices. We have 4 devices. We have mentioned the fact that we have input devices, output devices, storage devices, and communication devices. Typical interaction between peripherals and computer systems can be human to machine, or machine to machine, or X to machine, right? And we've looked at broad range of examples here. Of particular interest, I guess, is communication devices. This will come up in EDU 1020, and then there's a dedicated, I think, course. I don't know if it's 4th year or something, centered around computer networking, right? So again, an appreciation of how data is transmitted on the network. But fundamentally, for you to be able to interact with remote devices, you need communications devices. And then also, we highlighted the fact that a nice way of thinking about how data is transmitted to and from a computer is from the perspective of the human senses. And this is mostly applicable to peripherals that involve human-to-machine interactivity, right? All right. I do hope this was clear enough, and we're setting the stage for our discussion of the I/O subsystem. And in the I/O subsystem, we get to look at different techniques that are used to transmit the signals coming in from peripherals to the CPU. Because remember that fundamentally peripherals will be used to facilitate interactivity between input-output devices or peripherals with the CPU. So we're going to look at various techniques that are used to do this. Okay, great, and I'll see you very, very soon in the next batch of lecture screencasts. Thanks.